Okay, so this is a more complicated example from the problems in section 4.1, and we're going to try to determine whether f of x and g of x are inverses. Now, hopefully, you've read the chapter and understand by now that in order to figure that out, you've got to test to see whether f of g of x, meaning if you plug the function g of x in for f of x, if you work all that out, and in this one there's going to be a lot of work, because of the fractions, everybody's favorite, that needs to equal x. But you're not done there. You also need to check whether g of f of x is also x. So let's start with this one. And so this means I'm going to take g of x and plug it in everywhere I see an x in f of x. So this is going to look gnarly. And let's see what we got here. So this whole thing is going to go in for this x up here. So I'll have 2x plus 1 over x plus 1 plus 1 all over. And then again, I'm going to take all of this and plug it in for this x. 2x plus 1 over x plus 1 minus 2. Okay, so clearly this is ooky looking. And here's the trick for this part. You want to start with, just focus on the numerator by itself and the denominator by itself. We want to make these one big fraction before we go any further. So when you're trying to add a fraction, and in this case something that's not a fraction, or if you're trying to add two fractions, you have to have a common denominator first, right? So the common denominator for x plus 1 and 1, and you can think of that as 1 over 1 if that helps, would of course be x plus 1. So I'm going to multiply this term over here by x plus 1 on the top and bottom. Because again, I can't fundamentally change this from being a 1. So if I just make this top part x plus 1 but the bottom part stays 1, or vice versa, then you've changed this from being 1 to something else. But x plus 1 over x plus 1 still equals 1, right? Because if you divide those out, they cancel. You get 1 back. So now on top, I have 2x plus 1 over x plus 1 plus x plus 1 over x plus 1. Okay, and I'm going to actually do the same thing to the bottom here before I keep moving on. So again, same thing. This 2 is technically over a 1. So the way to get the common denominator for these two terms is to multiply this over here by x plus 1 on top and bottom. So now on the bottom, I will have 2x plus 1 over x plus 1 minus 2 times x plus 1 over x plus 1. And now I can combine things together, right? So if I combine the stuff in the numerator, so when you have a common denominator, you just add the stuff in the numerators and the denominator stays the same. So we would have 2x plus 1 plus x plus 1 all over x plus 1. If I do the same thing down in the bottom, I have 2x plus 1. And here, you've got to remember, we've got a minus sign here. And we're going to take this 2 and we have to multiply it through. So I've got a minus 2 times an x, so that would be a minus 2x. And then I've got a minus 2 times a plus 1, which would be minus 2 all over, again, x plus 1. Okay, so now we have unsimplified, but a fraction over a fraction. And what you can do in that case is if you're dividing, and this is, again, you can think of this as division. You're dividing one fraction by another. And if you recall, back to doing that when it was simple with just numbers, when you divide two fractions, you take the second fraction and you flip it, and it becomes multiplication. The shortcut to this is you multiply the terms in the middle together, and those go on the bottom. You multiply the terms on the outside together, and those go on the top. But first, before I do that, it might be a good idea to simplify this down a little bit. So we've got 2x plus x, so this one's going to be 3x. And then we've got 1 plus 1. So this top term is 3x plus 2. And then on the bottom here, so we've got a positive 2x and a minus 2x. Those are going to cancel, right? So we've got a plus 1 and a minus 2. So this whole thing just becomes negative 1. Alright, so I know it's a little messy here, but I'm running out of board. So, again, we're going to take this and times this, and I actually would recommend not simplifying things quite yet. So we've got 3x plus 2 times x plus 1 all over. And then we've got a negative 1 times x plus 1. Okay. So now if we simplify these, those will cancel, right? And we're left with 3x plus 2 all over negative 1. And of course, the important thing to note here is that if we simplify this down, we divide everything by a negative, we get negative 3x minus 2. But the important thing is that this did not simplify to just x, which is what we were wanting. So, since that did not happen, these two functions are not inverses. But again, if you check one, so you can stop. If you check one of them and it's not x, you don't have to keep going and checking the other. However, if this had worked out to be x, you would still need to go in and check the opposite, meaning that you would take f of x and put it in for x in g of x, and make sure that that also simplifies down to x. Alright, please let me know if you have any questions on these.